Okay, so you've had time to hopefully do the warm-up exercises. This is reviewing last night's homework and lesson. So let's look at these. The answers are highlighted, mostly, except for this last one, which should be, whoops, it erased my writing, should be -16. So the first one says, what is the constant of variation for the equation of the line that passes through those 2 points they gave you? Well, we know that constant of variation is slope. So if I know that k equals slope, I just find the slope by subtracting the y coordinates on the top and the x coordinates on the bottom. When I do that, I'm just careful with my signs, and I get -12 plus 3 over 6, which is -9 over 6, which reduces to -3/2. So if we go over to number 3, we read those famous words, y varies directly with x. And so as we talked about, we just immediately write y equals kx. And then I substitute what they tell me. It says that if y is 32, then x is 8. So I write 32 equals k times 8, and I figure out that k is 4. So now I write my special variation equation, y equals 4x. And then it says, I can actually answer the question, it says find x when y equals 64. So if y is 64, I plug that in, and 64 equals 4x, divide both sides by 4, and I figure out that x equals 16. I'll go back over here to number 2. It says, which graph represents y equals -2x? Well, we recognize that is a variation equation because it looks like y equals kx. So I know it goes through the origin, which all 4 of those choices do. And I know that the slope is -2, which is -2 over 1. So from the origin, I'm going to go down 2 and to the right 1. And the only one that goes down from the origin is either C or D. And sure enough, if I look at this one, I go down 2 and to the right 1. So C is the right choice. Number 4, I've worked for you. You'll have that in your notes, or you can look at it right now. This equals -16. It's exactly like number 3, except for the very last step. Your warm-ups where we reviewed direct variation, and we said yesterday that that is just a special example of a linear relationship. Today we're going to look at another special example of a linear relationship, and this is an arithmetic sequence. When you hear the word arithmetic sequence, it doesn't sound the same, but you recognize the word arithmetic, I hope. And so that is a big clue on what these sequences involve. An arithmetic sequence is a sequence of numbers that increase or decrease at a constant rate. There's that special phrase again. And we call that constant rate a common difference. We're going to call that D, and you'll see that come up in just a little bit. But that constant rate means we're either adding the same thing every time or subtracting the same thing every time. So you can tell in this first example, we go from 3 to 5, from 5 to 7, 7 to 9, and 9 to 11. We can tell those numbers are going up. So if it's an arithmetic sequence, the way it goes up is by adding the same thing every time. And sure enough, we see that it's pretty clear we're adding 2. This next example, if I look at these numbers, they're clearly going down. Well, if it's arithmetic, what makes it go down is subtracting the same thing every time. So I look at that, and sure enough, 33 minus 4 is 29. 29 minus 4 is 25, and so on. Now you can obviously think that also as adding a negative. So that's still how we get the common difference. You can either think of it as subtracting or adding a negative number. So arithmetic, if you think about that word, early on, the very, very beginning of your arithmetic days, the first things you learned were adding and subtracting. And so that is what's involved in an arithmetic sequence. You're either adding the same thing to get each term, or you're subtracting the same thing to get each term. So today's lesson, as we talk about these arithmetic sequences, we have 2 main goals. We're going to learn how to recognize if something is an arithmetic sequence or not, and then we're going to learn how to write a general equation for an arithmetic sequence. So that's where we're headed. So first, let's look at how do we recognize if something is arithmetic or not. So here's example A. It says determine whether this sequence, I'm going to highlight it, -15, -13, -9 is an arithmetic sequence or not. So first let's ask ourselves, are those numbers getting bigger or are they getting smaller? And it looks like they're getting closer to 0, right? From being very negative to being less negative. So that means the numbers are getting bigger. So I need to ask myself, am I adding something each time since they're getting bigger? And sure enough, if I go from -15 to -13, if I add 2, that works. So I'm adding 2 each time. So yes, that difference is constant between each term. So it is arithmetic. Let's look at this next example. Okay, we've already done the work here for you, but if my terms are 7/8 to 5/8 to 1/8 to -5/8, we figured out from here to here, I did get smaller, right? And 7 to 5 means I subtracted 2, so that's subtracting 2/8. But from here to here, I subtracted 4/8. So that is not a common difference. Those are not the same, right? And then this one is not the same. So you're not adding the same thing or subtracting the same thing. So that is a no, because the difference between the different terms varies. It is not constant. If it is constant, then it is an arithmetic sequence. Now, what's important, I think, to realize that you can take these series or sequences and put them in a table just like information we've been used to looking at. So I want to just introduce you to that so you can see that we're not dealing with something that different. If we make these tables, the X is our counter, first term, second term, third term, okay? And Y is the value of that term. So let's look at the sequence that we said is -15, -13, -11, -9. So those are actually the terms of the sequence. -15, -13, -11, -9. And I think you agree. You could tell me what comes next. Go ahead and fill in the last 2 squares. We said we're adding 2 each time, so that would be -7 and then -5. X, for these sequences, X is just a counter. The first term is -15. The second term is -13. The third term is -11. Fourth, fifth, 6th. So that's how the table works. We just have the counter, we're counting the counter, and then the actual term itself. Okay? So then we can see if we're comparing the rate of change here, these are going up by 1 each time, right? Like we were doing in last night's or the night before last homework. And these we can see are going up by 2, just like we've already said. So the rate of change is 2 over 1. So our constant difference is 2, just like we said. So our table agrees. It's just another way of looking at the information. Now, if I get ahead of you on these notes, they will be in the content library completely filled in. You can go back and look at them later. So now let's do our own work. Let's look at this example, example number 2. It says find the next term. So they've given us a sequence, -8, -11, -14, -17. They want us to find this, this, and this. 3 more terms. Okay, so first of all, let's decide if it's arithmetic. Well, they told us it was, so ding, ding, ding. Okay, if it is an arithmetic sequence, we are either adding something each time or subtracting something. So are these getting bigger or are they getting smaller? Or they're getting more negative, so that tells me they're getting smaller, right? So I am subtracting something each time. So since the terms are getting smaller, we are subtracting something. So what are we subtracting? Well, if I go from -8 to -11, you should agree those are 3 units apart, but I am subtracting because I'm getting smaller. Is -8 minus 3 -11? Yeah, so then we check ourselves. Is -11 minus 3 -14? Yes. Negative 14 minus 3 is negative 17. Negative 17 minus 3 is negative 20. Negative 20 minus 3. And that is the last one. So once you know the common difference, you can generate as many terms as you want. And this time it was negative 3. All right. I'm going to give you a moment to do this problem. It says find the next 3 terms of the arithmetic sequence, 58, 68, or sorry, yeah, 58, 63, 68, and 73. So your first step is to find the common difference, D. And you notice the numbers are growing. So to go from 58 to 63, what do I have to add? And if you're not sure, you can subtract, obviously, to get 63 minus 58. Is it? And then 63 to 68. 68 to 73. So we know that the common difference is 5. So 73 plus 5 is 78. That's the only one that starts with 78. So our answer is A. 78, 83, and 88. All right, now what happens? Let's look at this question. What happens when we want to know a number that is much further down the sequence, but we don't have the time or the patience to keep counting? That's when we need a general formula. And that's what I'm getting ready to give you, is a general formula so that we don't, what if we wanted the 50th term up here? Well, we don't want to have to keep listing out until we get to 50, right? That would take too long. So there's actually a general formula that we're going to learn how to use. And that general formula, it looks complicated, but it's really not. So you're going to have to know that. So the nth term, so maybe you want the 50th term, or you want the 100th term of a sequence. You can figure that out by using this formula. So we need to write down what these different things mean. A sub n is the nth term of the sequence. You don't know which one it is. It's unknown. Perhaps. A sub 1 is the first term, always. That little 1 means it comes first, the first term. I'm going to erase the word unknown here. Sometimes they will tell you, but basically it's some term far down the line. Whatever n is tells you what term it is. D is the common difference, we've already talked about. N is the term number, so it's the first term or the 5th term. Okay, first could be the 30th. So N is like that counter that we talked about. It counts the terms. So once you understand, those are the building blocks of the formula, you just put in what you know and you write your formula. So let's use it. It says write an equation for the nth term of the arithmetic sequence 1, 10, 19, 28. So step 1, find the common difference before we even need our formula. So are they going up or down? They're increasing. So it looks like I'm adding what each time? So the common difference is 9, because I added 9 to go from there to there. Added 9, added 9. Okay? Now, if we're going to write our formula, we need all of these pieces, right? Now, a sub n, we don't know yet. That's our formula, because we don't know the nth term. So we don't know a sub n. Do we know a sub 1, the first term? That is 1. And we know the common difference. And then n we're going to use. Okay? Just to kind of give you a heads up, these are our variables here. This is like our x and our y. Okay? So if we write the formula, we know that a sub n equals a sub 1. You can look back up at the top if you need to, but you're going to memorize it eventually. Plus, you use parentheses, you do n minus 1 times the common difference. And you're going to plug in the values you know. Okay, we already said a sub n and n, those are our variables. Okay, we're going to leave those, but we are going to put in 9 and 1. So I'm going to write a sub n equals, what is a sub 1? 1. Plus, I don't know what n is, so I have n minus 1, and I do know what d is. D is 9. Now, simplify. So we're going to do a sub n equals 1 plus, I'm going to distribute. I get 9n minus 9. Combine like terms. And I get a sub n equals 9n minus 8. That is our formula. I'm going to pause for a moment. Okay, so we ended up with this equation right here. That is the general formula that says the nth term is 9n minus 8. So then it says, we can generalize this a little bit or see why it's useful. So suppose now we want the 12th term. Well, the 12th term, that means n is 12. So we go back to our formula that says a sub n equals 9n minus 8. But I just said I want n to be 12. So that means that a sub 12, which means the 12th term, that's what that says, that's just fancy notation, the 12th term is 9 times 12, because that's what n is, right? Minus 8. And 9 times 12 is 108. Minus 8 equals 100. So what that says is the 12th term is 100. So instead of having to list them all out, this formula helps us find it. Take a look at this and then we're going to be finished. You should be able to look at that and realize that is linear. Linear. We don't have an x and a y, but the n, that is like our x, and that is like our y. And it follows all the rules for a linear equation, right? If it looked like y equals 9x minus 8, no variables with exponents, no variables in the denominator, and no variables multiplying each other. So an arithmetic sequence gives us a linear equation. It's pretty cool. Your homework will be similar problems to this. So look at your notes to help yourself, or you can look in the book for examples. And again, I'll have these notes exactly as you see them in the content library. So I missed you guys today. I'll be here for back work, so if you want to come ask questions about this, feel free. And I hope you guys have an awesome day. Be good. You rock.